Hey guys, Mr. Stevens here. Our next lesson is going to be on the topic of similarity and scale factors. We need to just review what similarity means from back in stage 4 and 5 and see how we can use it and apply it to scale drawing by using scale factors. So, if you don't remember what similarity is, similarity refers to objects that are the exact same shape but just different sizes. These pieces of cake are similar because they are exactly the same shape, exactly the same angles and everything, but the size of, say, this line is different in all the shapes. So a scale factor is these are two similar rectangles. The ratio of their sides is the same and all the angles are the same. The number that we multiply 20 by to make it 40 is the same as the number that we multiply 5 by to make it 10. Or another way of thinking of that is 40 divided by 20 equals the same number as 10 divided by 5. And this number here, 2, is the scale factor of these two similar shapes. That's how we apply scale factor. When we have, that's the definition of scale factor. When we have two shapes that are similar, like A and B are, the number that we have to multiply the smaller shape by to get the dimensions of the larger shape, or the reverse process is also true. We can divide the dimensions of the larger shape by the scale factor and we will get the dimensions of the smaller shape. So some points here to remember about exactly what similar figures are. Like I said, exactly the same shape but different size. So practically what that means is that corresponding angles have to be exactly the same and corresponding sides have to be in the same ratio. And that's where our scale factor comes in. Scale factor is the amount the first shape is enlarged or reduced to get the second shape. So, yeah, we've already talked about that here. Let's move on and just look at another way we can use scale factor before we do some examples is we can also use it on area. So in the example we had before, we had a shape that was 20 by 5 and then a shape that was 40 by 10. So the shape over here has an area of 100. It was millimeters, wasn't it? And the shape over here is 400 millimeters squared. Now, the scale factor that we used on these dimensions was times 2. The same scale factor can be applied to the area, but you just have to square it, which in this case is 4. And we can see quite clearly that 100 times 4 gives you 400. So that's one more application of scale factor we're going to use here today. So let's look at a couple of examples. The first example is calculating the scale factor. And it's very easy to do. Firstly, I think it's easier to start with the larger shape. Okay, and you have to make sure that you have the corresponding sides matched properly. So we want to match the shorter side of the rectangle with the shorter side of the rectangle, and match the longer side of the rectangle with the longer side of the rectangle. And then you take the side from the large shape and you divide it by the side from the smaller shape. And you can do the same thing with the other pair just to check that the shapes truly are similar. And the answer that you get here should be, firstly, it should be the same if these two shapes are in fact similar. You will always get the same number here. And the number that you get is in fact the scale factor. So that's the answer to this question. The scale factor of these two similar rectangles is 3. So another thing we can do with the scale factor is we can calculate the length of an unknown side. So we have our pairs of matching sides here. This 10 goes with the unknown side, and 48 and 8 are the other pair of sides. So we can use the 48 and the 8 to find out what our scale factor is, the same way we did it up here. We took the long side and divided it by the short side. We've come up with our scale factor. So now what we can do is, before we did this, we divided the other side by the other side, but now this time we don't know what x is. So what we need to do is to get x by itself here. If you remember doing equations in stage 5, you end up with x equals 6 times 10. To figure out the unknown side here, we take this known side and we multiply it by the scale factor. So the length of x is going to be 60. And the last type of question you're going to get is using area, the scale factor, and applying it to area. So we have two matching sides of this triangle that we're given a length for, 5/2, and we're told the area of this triangle is 3 centimeters squared. So that means that the area of this triangle is going to be the scale factor squared times the area. So first of all, the scale factor equals 5/2, so the squared scale factor equals and then we'll take this number here and we'll multiply it by the area. Which equals 75/4. It doesn't, I'm sorry that this question doesn't really come out to even numbers, but the process is the same, and you are able to do all of this in your calculator. If all you put in your calculator, instead of doing these steps like I did, because I did this in my head, you would be able to put into your calculator, just straight in one go, you would put the scale factor squared times by 3, and that would give you the answer. Okay, so again guys, you have 6 questions here to complete on page 198. Thank you.